All right, guys, welcome to our Unit 11 Quiz 2 study guide. Let's go ahead and get started here. It says, use your calculator to solve the equation for theta. We're looking for degrees between 0 and 360, and we want to round our answers to the nearest degree. So since we're using our calculator, that means we're not going to be using the unit circle to solve these. We're just going to use our calculator. And what we're going to do then is we want to get the theta by itself, and the way we do that is by doing the opposite of sine on both sides of the equations. Now, the opposite of sine is arc sine, which looks like this. So that's what would happen if you do it on the left side. On the right side, if you do arc sine on the right side, it's going to cancel the sine out and just leave you with theta, which is what we wanted to do. From there, we punch it into our calculator, and we end up with negative 12.7. But remember, we want to round this to the nearest degree, so we're going to say that's negative 13 degrees. Now, as you guys can see, that is not in between 0 and 360. Okay, so the first thing that we're going to want to do is we're going to want to find the positive coterminal angle for that by adding 360 degrees to it. And that gives me 347. So there's going to be our first answer. Now to find the second answer, because very often these are going to have two answers, we're going to use graphing to do that and understanding how the symmetry of sine works. So 347 degrees is going to be like somewhere right around here. And we're looking for another sine value, which is a y value that would match that. In other words, we're looking for a point on the unit circle that would have the same height as that one. And it turns out that when you're working with sine, the one that matches it will always be to the left of it. So there's one over there. So from there, we want to go ahead and use our symmetry. Okay. So I know that this is 347 degrees. I know that this is 13 degrees. Therefore, over here, this is 13 degrees. So if I wanted to find this other angle over here, that'd be 180 plus 13. So we end up with the second angle as 193 degrees. Okay, and so that's how you'll do it. So first thing we do is we do the arc trig functions. The next thing that we do is we turn it into an angle between 0 and 360. From there, we graph it, and we use the symmetry to find the second answer. All right, let's go ahead and take a look at another one of these types of problems. So this is cosecant, and as you know, there's no cosecant button on our calculator. So what we do is we take the reciprocal on both sides. So the reciprocal of cosecant is sine, and the reciprocal of the reciprocal of negative 7.2 is 1 over negative 7.2, which if we punch that into our calculator, we will get the following. About it's negative 0.139. Okay, so now we've got this, and after this, it just becomes like the last problem that we did, number 1. We do arc sine on both sides. So let's go ahead and do that on the calculator. And I end up with negative 7.983. But if I just round that to the nearest degree, that's going to be negative 8 degrees. But once again, we don't want negative angles. We want it to stay between 0 and 360. So we add 360 to that, which gives me 352. So one of my answers will be 352. Now we go ahead and use symmetry to find the other one. We already know that 352 is going to be like right about there. It's a pretty similar spot as the last one that we had. And we know that this orange angle here is 352 degrees. And we know that this little piece right here would have to be 8 to complete the 360, right? We know that the one that matches sine would be the one to the left, so it'd be over here. So I know that this has to be 8 also, and therefore the angle of this second one is 180 plus 8, and therefore my second answer is 188 degrees. And there we have it. Let's go ahead and take a look at number 3. So now we're talking about tangent. There is some different stuff when it comes to tangent and cotangent, so let's see what we can find there. All right, so we do have a tangent button on our calculator, so the first thing that we're going to do is we're going to do the opposite of tangent on both sides, which is arctangent, of course. So if we do arctangent on the left side, it cancels out the tangent, we're just left with theta. If we do arctangent on the right side, we get this, which once again, that's something that we're going to be plugging into our calculator. So let me take a moment to do that. And I get 81.2. And we're just going to round that to 81 degrees. Okay, so that's one of my answers because that is between 0 and 360. Okay, so I'll write it up here at the top, 81 degrees. And then after that, we're going to use symmetry. Now, tangent has different symmetry than sine does. On our last two problems, sine has its symmetrical answer to the left, but with tangent, it's diagonal. So let's see if we can find where it is. 81 degrees would be right about here. Now for tangent, the symmetrical answer to it will be directly diagonal to it, so across from it over here. Okay, so from here, we're going to use some basic symmetry to find our next answer. So I know that this is 81 degrees, right? That was my first answer. Now I also know that since that's a straight line from here to here, that's 180 degrees more. So basically, if I just take 81 and add it to 180, that'll tell me the other answer. Okay, so I end up with 261 degrees. Okay, now you can either add 180 or sometimes you can subtract 180. On this one, I would want to add 180 because if you add 180 to 81, you do get an answer between 0 and 360. But other times, if you end up with an answer that is down here instead in this quadrant, you would actually want to, you would end up having to subtract 180 from it. Anyway, we'll see an example like that, I think, on the next one. Let's go ahead and take a look at it then on number 4, cotangent. All right, cotangent. We do not have a cotangent button on our calculator, so when that's the case, we go ahead and we do the reciprocal. So the reciprocal of cotangent is tangent, and the reciprocal of 1.64 is 1 over 1.64, which I'm just going to use on my calculator here to find what that would equal. And I'm getting 0.60. Well, it's actually going to be 0.61. There we go. All right, then we go ahead and we have this new equation then that we're going to work with. Want to find theta, so we go ahead and do arctangent on both sides of our equation to get the theta by itself. And let's see what we get from that. I get 31.4, which if you want to round that to the nearest degree is going to be 31 degrees. Okay, so that'll be my first answer, 31 degrees. If you want to find the second answer, like we showed you on the last one, you could just add 180 to that. So 180 plus 31 is 211. So I thought this was going to be one where you have to subtract 180 instead, but I guess not. Maybe it'll be the next one. Let's go ahead and take a look at number 5. All right. So we have a tangent button. So we're just going to start off by doing arctangent on both sides. Let's see what that gives us. And rounding it to the nearest degree, you're going to end up getting negative 83. 3 degrees. Okay, now that's not in between the angles that we want. So we're going to add 360 to that to turn it into a positive coterminal angle there, which is 277 degrees. So that'll be my first answer, 277 degrees. Okay, now 277 degrees on the unit circle is down here, approximately. And so the symmetrical answer for tangent will be diagonal from that, which is somewhere up here. Now, if I'm doing this, that's 277 degrees. I don't want to find the other one by going this way, because if I do that, I'm going to be adding 180 to this, which is going to go past 360. I don't want that. So what we're going to do instead is we're going to go the other way. I'm going to subtract 180 from it to find the other answer, which is over there. So 277 minus 180 would be 97 degrees is my second answer. Okay, and there you guys have it. Let's go ahead and take a look at one more of these types of questions. Number 6. All right, cotangent. We do not have a cotangent button, so we start with the reciprocal on both sides. The reciprocal of cotangent is tangent, and the reciprocal of negative 4.7 is 1 over negative 4.7. And if we simplify that on our calculator, we get negative 0.213. And then to solve for theta now, we do arctangent on both sides. So let's go ahead and punch that now into our calculator and see what we get. We get about 12 degrees for that, if we round it to the nearest degree. Oh, it should be negative, actually, my bad. So once again, we don't like negatives, so I'm going to add 360 to that. And that should give me my first answer, which is 348 degrees. So there's my first answer, 348 degrees. We'll go ahead and graph it. 348 is going to be somewhere like around here. So therefore the matching one will be somewhere on this side. And once again, I don't want to add 180 to it to find the other angle, because that's going to go past 360 if I do that. I want to subtract 180 from it this time. So let's do 348 minus 180 to find our second answer, which is 168. And there's our two answers. Okay. And just to kind of show you guys the angles, 348 looks like that, and the 168 looks like that. So those are the two angles that we're looking at. It's not this blue line that I've traced. That was for subtracting 180. But anyway, so there's the end of those types of questions. Let's go ahead and move on to a different type of question now. On this one, we're solving some equations, and they have some outside operations. And so basically, we're going to just use the steps for those, which I think was less than 11.4, if I'm not mistaken. Also notice that we're not using our calculator on these ones. We're going to be using our unit circle instead, so we're going to be getting some exact answers rather than rounded answers. So when you have equations that have outside operations, the first thing you want to do is you want to get the trig function by itself. So I want to get rid of the -3 and the 4 over there. So let's go ahead and begin. The first thing I would do is, if you have any adding or subtracting, that's probably the one you want to start with. Then after that, you're going to divide. So I've got secant of theta. Now, on our unit circle, we like sine, cosine, and tangent. We don't really like secant. So what we do is we do the reciprocal of these once again, just like we did on the calculator. The reciprocal of secant is cosine, and the reciprocal of 2 is 1/2. Now, you could use your calculator at this point and do arc cosine, but like I said, we're not doing that this time. We're going to use our unit circle. If you did use your calculator, you'll get the right answer, but it will be in decimal form. But since we are doing this with a unit circle, we want the exact form, which is written in the form of fractions with square roots and stuff. So you're going to want to get out your unit circle, and you're going to want to find where cosine is equal to 1/2. Now you have to remember that cosine is the x value, And the x value, we're looking for where does the x value equal a half? Well, there's one place here, up here at the top, where x equals 1/2. And there's another place down here where x equals 1/2. And if you look at your unit circle, you'll see there's a half for the coordinate there in the x location and a half for the x coordinate here on that location. And so now we need to ask ourselves, what are those angles that go with it? Well, on our unit circle, this one up here is, you could write it as either degrees or radians. You could tell up here, since they're wanting degrees though. So that's going to be theta equals 60 degrees. So that's this angle. And then this one way over here, that one would be 300 degrees. And so there's our two answers. All right, let's go ahead and move on to another question like that. Once again, we're going to do our addition first, or subtraction, depending on what the problem is. And then we do our division second. This should not have been a negative, that was a positive. So -4 divided by +4 is a -1. Now cosine equals -1 in only one place on our unit circle. Cosine is the x value. So when is the x value equal to -1? And that happens only over here at that particular location. That's where x equals -1. And so there's only one answer for this problem. It's 180 degrees. A lot of times, anytime you have an answer on the axes, you'll only have one answer. Not always, but a lot of times that'll be the case. All right, let's go ahead and take a look at number 9. Now, sometimes you'll see these types of questions with outside operations, and they're going to have fractions. Nobody likes fractions. So the first step that we take when you have the fraction problems is to go ahead and multiply everything by the denominator so that you can get rid of those fractions. So what I'm going to do is I'm going to multiply everything by 5. Okay? So I'm going to multiply this -1 here by 5, and that gives me -5 minus. Then I'm going to multiply this by 5. Now, when I multiply this by 5, what happens is, if you multiply it by 5, these cancel, and it just leaves you with -9. So basically, it just gets rid of the denominator. You don't actually end up multiplying anything at all. You end up canceling stuff. Still have our cosine there. All right, next one. Same thing happens here. If I multiply 6/5 by 5, it cancels the denominator out and just leaves me with the -6. And then here, if I multiply that by 5, I get -10 cosine of theta. So now we don't have those pesky fractions anymore. You'll also notice that what's different about this problem is I've got cosine on both sides. We only want one cosine to be there, so we're going to move one of the cosines over. Technically, it doesn't really matter which one you move. I like to cancel out the bigger ones, or sorry, the smaller one. -10 is smaller than -9, so I'm going to add 10 cosine theta to both sides of my equation. That way it's gone on the right side now. And on the left side, I've got -9 plus 10, which is 1 cosine theta. I'm not going to put the 1 in the front. You can, I choose not to. And it's a positive 1 now because -9 and +10 makes +1. But we still have our -5 there. All right, and then the next thing we got to do to get cosine by itself is you're going to add 5. So remember, the goal is to get cosine by itself. So that leaves me with a -1. Now, we actually solved that problem already on the last page. It's the same question where cosine equals -1. That's over here. And so the answer is 180 degrees. So that one had a couple of things that were a little bit different to keep in mind. How to get rid of fractions. And also, if you have cosines on both sides, just put them together, basically, right? So let's go ahead and move on and do another question here, number 10. This one has another little twist to it. We have some squares involved, and we'll see how to deal with that. So first of all, I don't want two different tangents on these sides of the equations. I'm going to go ahead and add this tangent on both sides. Once again, it doesn't really matter which tangent you choose to move. -2 plus 1. That's going to be a -1 tangent squared theta. So by adding 1 tangent squared theta on both sides, I get this. And we don't like that negative in the front, so I'm going to get rid of that. Dividing both sides by a negative, I get tangent squared theta equals positive 1. So notice my first step was to put the tangent squareds together, and after that get the tangent squared by itself. Now, the last step here is I want to get rid of the square, and the way that we do that is by taking the square root on both sides. But you have to remember that when you do that, you take the square root of this number over here, which in this case is 1, and you get two answers. You get a positive and a negative. So we actually end up having two equations as a result. So when you have the square problems, you're going to get twice as many answers as you normally would because you get two outcomes because of the square. So now I need to solve both of these. Where does tangent of theta equal 1? Now for tangent, you need to look at your tangent unit circle. And tangent equals 1 in two places. One of the places it equals 1 is here, which is at 45 degrees. The other place it equals 1 is down here, which is at 225 degrees. Then we want to find where does tangent equal negative 1. One of those places is up here. That is at, what is that? That's 135 degrees. And the other one is diagonal to that, which is over here, which is 315 degrees. So there are four answers to this problem. Usually there's just two, but there's four. And that's because we had two equations, and that's because we had a square, which gives us a plus and a minus. So keep in mind, when you have a square, you'll get twice as many answers as you typically would. All right, so that takes care of solving trig equations with outside operations. I guess there's one more. Let's do one more of these. Why not? It's on there. All right, start by adding 3 secant squared theta on both sides. Put those secants together, right? That just leaves a 4 on the left, and on the right side, a negative 2 and a positive 3 makes 1 secant squared theta, and I'm not going to write the 1. And now we've got the secant by itself, so we're going to go ahead and we're going to square root both sides, which gives me the following. Secant theta equals plus and minus 2. So I have two equations here. Before I write I guess we'll write it. So we have secant theta is equal to 2, and we have secant theta is equal to negative 2. Now, we don't have secant on our unit circle, but we have its reciprocal, which is cosine. So I'm going to take the reciprocal on both sides. So I get cosine of theta equals a half, and I also get cosine of theta equals a negative half. And now I need to solve for both of those. Now, cosine of theta equals a half up here and also down here. That is at the angles 60 and 300. But we also want to find the places where cosine of theta equals a negative half. That is here and here, which is 120 degrees and 240 degrees. And so there are four answers there once again, and that's because of the square. All right, moving along. So for the next few problems, we have the same type of question. It's just that instead of using our unit circle, we're going to be using our calculator. So step one is the same. The first few steps are the same. That is, we're just going to get the signs together. So I'm going to add 5 sine theta on both sides. Negative 2 plus 5 is 3, so I've got 3 sine theta now. Then I'm going to subtract the 4.4 on both sides. Remember, my goal here is I want to get that sine of theta by itself. That's going to be 0.6. And then I'm going to go ahead and divide both sides by 3. And now I finally got sine by itself, and I have sine of theta equals 0.2. So from here, we're going to go ahead and do arc sine on both sides of the equation, which will give me the following. And that's a calculator time, so let's go ahead and do that. Arc sine of 0.2 is about 12 degrees approximately. So using our symmetry, for sine, 12 degrees is here. And for the symmetrical answer that goes with that, it will be on the opposite side to the left, going that way. And so I know that this is 12 degrees here. And so what would this angle be? Well, it would be 180 minus 12. And so that looks like it would be, it's a 6, my bad, 168 degrees. So there's our two answers. And that's it. So the only difference is once you get to this step, you use your calculator and then you do what we've done before with finding answers using calculators. So it's just basically like putting two of the ideas we've learned together. Let's go ahead and take a look at another one here just to kind of bring it home. We're going to start by moving the tangent together. So I'm going to subtract 2 tangent on both sides here, thereby getting rid of it on the right side and making 2 tangent on the left side. Next, we're going to do our adding or subtracting. We're going to do our division. And then we're going to do our arctangent. Let me punch that into my calculator and see what I get. That's about negative 74 degrees. Now, we don't like negative answers for this problem because we want to do it between 0 and 360. So I'm going to add 360 to that to get the positive coterminal answer, which is about 286 degrees. So there's my first answer. Oops. There's my first answer. And then 286 is located somewhere like down here. For tangent, the symmetrical answers are diagonal to it. So what I'm going to be doing is I'm going to be subtracting 180 from 286 to find the second answer, which is about 106. So there's our two answers for that particular problem. Moving along. So this question is asking us to find the general solution for the equation, and they want us to do it in degrees. So let's go ahead and just solve it, and the specifics of what that means will come up in a second. So let's begin here. So the first thing I'm going to do is divide by 4. Then we don't have a cotangent on our unit circle, so we're going to use the reciprocal. The reciprocal of cotangent is tangent. The reciprocal of -1 is still -1. It doesn't change. And where does tangent of theta equal -1? If you look on your unit circle, that happens in 2 places. One is over here, and one is over here. And those angles in degrees would be 135 degrees and also 315 degrees. Okay. So those are our two outcomes. Now those are specific solutions on the interval from 0 to 360. But we want the general solution. And that means a formula that will help us find the infinite number of possibilities that exist. Okay, and so here's how this works. If you're dealing with sine, cosine, secant, or cosecant, the general solution is the answer that you get using the strategy that we just did, plus 360 times n, where n represents any integer. And the reason that works is because if you take your answer and you add 360 to it, you just get a coterminal angle that matches it exactly. But if you're dealing with tangent and cotangent, it's a little bit different. You take the answers that you got and you add 180 to it. Okay, add 180 in. Now, for these particular types of problems, also, for sine and cosine, you get 2 answers. So you have answer 1 and you have answer 2. And the general solution would have to include both of them. But for tangent and cotangent, even though you get 2 answers, we only use one of them. You don't have to include both. It could be either one of them. So if you're doing like a multiple choice test, don't be surprised that they might pick one or the other. But the point is you really only need one of them to get the answer. So let's go ahead and write out our general solution. So we just solved this and we found out that theta equals 135, and we also saw that theta equaled 315 degrees. Now, we don't need both of these for the general solution. We're just going to get rid of one. And we're going to take our answer that we got, and we're going to add to it 180n. And there's our general solution in degrees. And that's it. The reason you don't need the 355 is because if n represents any integer. So if you let n equal 1, 180 times 1 is 180, plus 135 is 315. So this formula represents both answers, really. All right, so let's go ahead and move on to number 15 and take a look at another one. So this is a cosecant problem. So for cosecant, instead of adding 180n, like we did on number 14, we're going to add 360n. But let's go ahead and get started and solve it out here. So I'm going to start by dividing both sides by -4. It gives me negative radical 2. Then I'm going to do the reciprocal on both sides. The reciprocal of cosecant is sine. The reciprocal of negative radical 2 is that, which, as you guys know, we want to rationalize that. That gives me that. So I'm looking on my unit circle for where the y value is negative radical 2 over 2. And on my unit circle, there are 2 places where that occurs. One place is down here, and the other one is down here. And those angles are 225 degrees and also 315 degrees. So there's my 2 answers. Now, since we're dealing with cosecant, we do need our general solution to include both answers. And we add to them 360n. And these are the formulas we could use to generate any number of solutions possible. All right. Let's go ahead and move on to number 16. Here's another one, just another general solution question. But this time there is a difference. They want us to write the answer in radians. So let's see. The first few steps aren't going to be that different. So let's do the first few steps and then we'll see where the difference comes in. So once again here, we're dealing with fractions, and we've talked about how to deal with that before. And the way we handle those fractions is we multiply everything by the denominator, right? So we multiply that, and we get negative 10. Multiply that, and we get 2 sine theta. And then multiplying this, if you multiply this whole thing here by 2, the 2's cancel, and you're just left with negative 10 plus the square root of 3. All right. Next step, we're going to add 10 on both sides. And they actually just both cancel. That's interesting. And then we divide. All right, so we're looking for, on our unit circle, where does the y value, which is sine, where does the y value equal radical 3 over 2? There are 2 places that occurs. One is here at 60 degrees. The other one is here at 120 degrees. So there's our 2 answers. Now we want the answers, though, to be in radians. And so this is where things are going to be different. We're not going to be using 60 degrees. Instead, we're going to use the radian equivalent of that, which is pi over 3. And we don't want 120 degrees, we want the radiant equivalent of that, which is 2 pi over 3 degrees. So we're going to use those instead. Now there's more of a difference. Let me clear up my page here. So typically what we would do is we would take our answers, right? And we would add to it 360n, right? But since we're doing radians, you don't do 360, you do the radiant equivalent of that, which is 2 pi n. And so that's how you'll do a general solution in radians. You want to make sure that your answers are in radians and that the period that you're adding to it is in radians as well. Okay, let's go ahead and move on to another question. I want to clear that denominator, so I'm going to multiply everything by 3. So multiplying that fraction there by 3 just cancels out the denominator and leaves me with the top. Multiply there, I get 12. Multiply here, I get 3 tangent. Let's go ahead and subtract 12 on both sides, getting rid of those 12s. And then dividing 3 on both sides. Get tangent of theta equals negative radical 3 over 3. And we want to look at our tangent unit circle for that. Our tangent unit circle has negative radical 3 over 3 located here, which is at, what radian is that? It's 5 pi over 6, I believe. And the other one is over here at 11 pi over 6. So those are our 2 answers in radians. And now when we're doing tangent, you don't need both of them. You just pick one of them. I would assume they're usually going to pick the smaller one. So we'll go with the 5 pi over 6. And then we're going to add to it. Usually with tangent and cotangent, we would add 180 in, right? But what's the radian equivalent of 180? It's pi in. So that's how you would write your general solution in radians for that one. And I was just looking at how my computer writes the answer. They went with the 11 pi over 6. They both work. They're both true. So just be prepared on your test when you're doing your multiple choice that you can write it either way, but you only need one of them. All right. Let's go ahead and move along to our next one here. Number 12. All right. So now this is kind of a subtle thing, a subtle difference. You want to pay attention to this portion up here. Okay. Now, if I say to you, just go ahead and solve between 0 and 360, those are like the problems that we did back on numbers. Well, let's go ahead and take a look at it because I don't remember which ones they were. Just a second. It's kind of like what we did on numbers 1 through like 11. Okay. So just basically using the calculator or the unit circle, just making sure your answers stay between 0 and 360. But when it comes to this type of problem that we're on now, which is asking us to find a solution on the interval that's not 0 and 360, what we're going to do is we're going to start by finding the general solution first, just like we did in the last few problems. And after that, we're going to use that to find specific or I guess we could say particular solutions on the interval they're asking. Okay, so if I give you any interval other than 360, rather than just doing the unit circle or calculator basically like we have, we're going to do the general solution and use that to find the specific answers on that interval. Okay, and so that's what the last few questions are focusing on, which was our most recent lesson, I believe. So let's go ahead and begin. So the first thing I want to do is I want to find, where does tangent equal 1? Well, tangent equals 1 in 2 locations. That would be here and here. Since we're doing degrees, it looks like that's going to be 45 degrees, and it's also going to be 225 degrees. Now, to turn this into a general solution, since it's tangent, I only need one of these, so I'm going to pick the 45 degree option, and I'm going to add to it 180 in. Now, that's not my answer, but I'm going to use that to generate as many answers as I want on the interval between between negative 360 and 60. So I'm going to pick a lot of different answers for n, and that's going to give me specific values for theta, and I want to get as many as I can between 0 and 360. So let's go ahead and start with letting n equals 0. So in other words, if I plug in 0 here, 180 times 0 is 0, plus 45 is 45. So if n equals 0, then theta equals 45. Let's go ahead and plug in 1 for n. So if I plug 1 in for n, that's 180 times 1 plus 45. Let's see what that comes out to. So 180 times 1 plus 45 is 225. Let's go ahead and do it again. Let's plug in 2. So if I plug in 2, what will that give me? That would be 360 plus 45. I'm pretty sure that's going to go past 360, so I'm going to skip that. So now let's start working backwards. I'm going to subtract 1. I'm going to plug in -1 for n this time. So if you plug in -1 for 80, then it's going to be 45 minus 180. Let's try that. And that gives me -135. That's still good because we don't want to go past -360. So let's do it again. If I plug in -2 and simplify it, I'm going to end up with -315. That's still good. But I'm pretty sure that if I tried to plug in anything else, like a -3, I'm pretty sure it's going to go past the answer we want. So I think we're done there. There's our possible answers. Okay? Now you don't have to do this chart if you don't want to. Really what you could do is you could just start with 45 and you could add keep adding, just add 180 until you can't add 180 anymore, and subtract 180 until you can't subtract 180 anymore. You don't have to do the plugging in thing, but you can. It works either way. All right, let's go ahead and take a look at another one. This one is also asking us to find answers between -360 and 60. So sine is equal to a half. That's when y is equal to a half, and that's here and also here. And those two answers are 30 degrees and 150 degrees. Now for sine, we have to use both of these. So we have 30 plus 360 in, and we have 150 plus 360 in. So we do have to do both equations for sine, cosine, secant, and cosecant. All right, so we're going to pick values for n, and we're going to plug them in for our answer to get our possible answers. I always like to start with 0 because that's going to be the answer that's here, so it's just 30. And that's one of our answers that we can use because that's between -360 and 60. And now basically if I were to plug in 1, that's like I'm just going to add 360 to 30. So let's do that. You would get 390. Now that is not a good answer. That's not between the options, so I'm going to kill that. If I were to plug in a -1, that's like subtracting 360 from 30. And so in that case I get -330, and that one works. Now if I were to plug in a -2, I'm going to get something that's past what I want. So this one's only going to give me 2 answers so far, 30 and -330. But we also want to go ahead and do this one over here. So once again, starting with 0, we get 150. And if I plug in 1 here, that's like I'm adding 360 to 150. So let's do that. That's 510. Now that's too much, so we're not going to use that. But if I plug in a -1, that would be like I am subtracting 360 from 150, and I get -210, and that one works. And I already know that if I were to do it again, subtract 360 again, it's going to go past what I want because we only want to be between -360 and +360. And so there's my 2 possible answers there. So we have 4 answers. The answers are -330, 30, -210, and 150. All right, let's move along here to another one. This one is in radians. So that's the only difference. It's the same type of question. It's just in radians. All right, so secant. Well, there's no secant on our unit circle, so we need to do the reciprocal first. Just like that. We also don't like having the square root on the bottom there, so I'm going to multiply the top and the bottom by the square root of 3. So that leaves me with 3 square root of 3 over 2 times 3. And these 3's cancel, so I'm just basically left with radical 3 over 2. There's that. So I'm looking for the places where the x value is equal to radical 3 over 2. And that happens here on the unit circle, and it happens here on the unit circle. And remember, we're doing radians for this particular problem, and so the two answers for that are pi over 6, and what's the other one? 11 pi over 6. And therefore, the general solutions are pi over 6 plus 2 pi, and 11 pi over 6 plus 2 pi n. So there's my general solutions, and now we can use those general solutions to generate our specific answers that are between negative pi and 2 pi. All right, so I'll do the first one here in blue. So we're going to pick numbers for n and get our answers for theta. So of course we want 0. That's pi over 6. Let's go ahead and plug in 1. So if I were to add 2 pi to that, well, obviously if I add 2 pi to anything, it's going to be bigger than 2 pi. So if I plugged in 1 here, we could go through the trouble of actually trying to calculate what that is, but there's no point because I don't want to go past 2 pi, which is what I have here. So if I add anything to it, it's going to go past it. So I'll just skip that one. But let's go ahead and plug in negative 1 and see what we get there. So pi over 6 plus 2 pi times negative 1. So in that case, I have pi over 6 minus 2 pi. Now I need to get a common denominator here for that. So if I multiply the top and the bottom by 6, I would get 12 pi over 6. And that's negative 11 pi over 6. Okay. Now, is that on this interval? And that's kind of hard for us to tell. And I think I gave you guys some strategies. One way you can tell is just by turning them into decimals to see. But another way is just by looking at the fractions only. So like, for instance, I want to know, is this less than negative pi? In other words, is it outside the boundary? Or is it still in between these two? Well, negative 11 divided by 6 is like negative 1 and 5/6, right? This thing goes from negative 1 to positive 2. So is negative 1 and 5/6 in between those two values? And the answer is no, it's not. So we're not going to use that one either. Okay, so this one really only gives us one answer. Let's go ahead and do the other equation now. I'll do that one in red. I'll make some space for myself here. So we've got pi over 6 as one of our answers. I'll go ahead and write it up here so I don't forget about it. So let's go ahead and plug in, of course, 0, which is 11 pi over 6. Now if I plug in 1 to this equation here, I already know it's going to go past 2 pi because here's 2 pi and I'm adding more to it, so we're not going to do that. Let's go ahead and do subtraction though. So what if I subtracted or plugged in a negative 1 instead? Will it fit in the interval between negative 1 pi and positive 2 pi? Let's see. Okay, so that's going to end up being minus 2 pi again, getting that common denominator. gives me negative 1 pi over 6. Okay, so once again, as you guys can see from up here, if we just look at the coefficients and ignore the pi's for a minute, we're going from a negative 1 to a positive 2. And the question is negative 1/6? Is that in between those two numbers? And the answer is yes, it is. So negative 1 pi over 6 is a possible answer. Okay. We could repeat this by plugging in negative 2. Let's go ahead and do that and see if it fits in there. Probably won't fit, but it's worth looking. So here we go, 11 pi over 6 plus 2 pi times negative 2. That's going to be 11 pi over 6 minus 4 pi. Common denominator. Subtraction, that's going to be negative 13 pi over 6. So, is negative 13 over 6, is that in between negative 1 and positive 2? The answer is no, because 6 goes into 13 twice with 1/6 left over, right? So negative 2 and 1/6 is not in between negative 1 and 2, and therefore we wouldn't be using that one. So we have our other two answers here. So we have pi over 6 as an answer, 11 pi over 6, and then negative pi over 6. Let's do one more of these guys here, cotangent. So with cotangent, we start by doing the reciprocal on both sides. We don't like having square roots on the bottom, so we rationalize. And tangent of theta is equal to radical 3 over 3 here and here. And it doesn't really matter which one you pick, but this one is pi over 6, and this one is 7 pi over 6. But with tangent, you don't need both of these for the general solution. You just pick one, and you add pi into it. So there's our general solution. And now we want to generate some answers that are between negative pi and positive 2 pi. All right, so let's begin. I'm going to plug in 0 for n, and that will just leave me with pi over 6. What if I plug in 1? Let's see what that gives me. Pi over 6 plus pi times 1 is pi over 6 plus pi. Getting a common denominator, we end up with pi over 6 plus 6 pi over 6, which is 7 pi over 6. So, is 7 pi over 6 between negative 1 and positive 2? Is 7 over 6 in between those two numbers? 6 goes in there once with 1 left over. 6 goes into 7 one time and with 1 left over. So, is 1 and 1/6 between negative 1 and 2? And I say yes, it is. And so that's a good answer. We'll keep that one. Let's go ahead and plug in 2 and see if that fits. Get that common denominator so we can actually add those together. So 13 over 6. Is 13 over 6 between negative 1 and 2? 6 goes in there 2 times with 1/6 left over. So is 2 and 1/6 between negative 1 and 2? And the answer is no. So we won't include that one. All right, what about negative 1? Let's plug in negative. We want to start working our way backwards, seeing if that'll work out to give us another answer. Common denominator. One minus 6 is negative 5 pi over 6. All right. So, is negative 5 over 6 in between negative 1 and negative 2? Kind of difficult to tell. In this case, I think I'm just going to go ahead and change it into a decimal and see if that helps. That's negative 0.83. I would say yes, that is in between there, right? Because it's bigger than negative 1, but it is less than 2, so that one works. So we have negative 5 pi over 6 as another answer. Now we could test negative 2, but this is really close to negative 1, so I think that if I were to subtract another pi from it, it's going to end up going past it. So I'm pretty sure our 3 answers are going to be right there. And we'll just go ahead and call it quits with that one. All right, I think that'll do it for our study guide. So hopefully that was helpful, and we'll see you guys in class for your quiz. Till then, have a good one.